Welcome back. This is part 2 of the APES Chapter 16 flip, and this is where we're really going to dive into climate change. What is it? What are the problems? Things along those lines. So uh, remember that when we talk about climate, we're talking about at least 30 years. So the change in average weather conditions over a period of at least 30 years is how we'll define climate change. Uh, Over the Earth's 3.5 billion year history, climate has changed many times. For the last 100,000 years, humans have lived in a relatively steady interglacial climate, so a thawing climate. So here's what you're seeing, or what you're seeing here, I guess I should say, is a graph of the average temperatures over the last 900,000 years. So you see there are lots of fluctuations. What we'll point out and what I'll try to emphasize throughout the rest of this course is the fact that this line slope is greater than any of the other line slope. That's a pretty steep warming trend right there that followed an ice age. Same thing there. Post ice ages, we have steep increases in average temperature. Over the last 200 years, atmospheric temperatures have risen with urban growth. Think about something like an heat island. The fact that heat and concrete and glass and steel hold heat longer than do dirt and trees and things like that. Rate of climate change has been accelerating since 1978, and past climate changes took place over thousands of years versus decades that the current climate change is taking place, in which the current climate change is taking place. Sorry about that. So evidence of past and current, when we look at uh, past climate changes, we can look at isotope levels in rocks and fossils and ocean sediments. Um, there are stromatolites in Australia that give us lots of great data on what the climate has been like in the past. There are tiny bubbles and layers of soot and other things like dead bugs and things along those lines that are in ice cores in glaciers. So that gives us a pretty good um, idea of what the atmosphere was like when that glacier formed. And then pollen from the bottoms of lakes and bogs, same kind of deal. Tree rings, the thickness of the tree ring represents the amount of rainfall in that year. Um, and then at present, we have tons of measuring stations around the world and satellites and things like that that are showing, certainly since the 80s, we've had satellite data that shows this spike in temperature. Notice there are some drops in there, that it's not just streaming upward. There's fluctuation. I'm talking about average surface temperature, so there is fluctuation, but notice we're higher here than we have been in the last 130 years. So this is the report, kind of from all of these groups that are researching climate change. Climate change is happening now, is most likely caused by human activities, and will very likely worsen unless we act to stop it. We need immediate and sustained action. The sooner we act, the better off we'll be. But what's happening right now? Our average global temperature is rising sharply. 9 of the 10 warmest years on records have taken place since 2000. Um, Almost every year we add to that. Glaciers and summer Arctic sea ice are shrinking. We've seen that already. Permafrost is shrinking. Sea levels are rising. There are more atmospheric greenhouse gases. And many species are moving towards the poles, expanding ranges for invasive diseases and things like that. Something like Zika wouldn't have been a problem 15, 20 years ago because the climate wouldn't have supported those specific butterflies, or I'm sorry, specific mosquitoes moving north. Um, Greenhouse effect is magnified by the Industrial Revolution, mostly because the Industrial Revolution was accompanied by lots of factories that pumped out lots of carbon dioxide. Of course, our uh, carbon footprint has increased as a result of that. It takes more carbon to make the things that we use, thanks to the technologies created during the Industrial Revolution. Carbon dioxide and heat uptake by oceans helps to moderate this effect and slows atmospheric warming, but that means it's going to affect the oceans as well and not just the atmosphere. And then cloud cover can also increase or decrease atmospheric warming because the clouds can trap heat either in or out. So what's the issue? The fact that we're heating up faster. Why is that a problem? Well, the fact that we're heating up faster can have long-lasting effects. Snow, ice, and permafrost are going to melt. We're going to lose glacial water supplies. Once they become salty, they become salty. Now they can refreeze and precipitate that salt out again, but that's a slow process. Permafrost loss is going to accelerate atmospheric warming. If you got something that's always frozen and that defrosts, that's going to take away a major source of cooling. Sea levels are going to rise because of the things up here. We're seeing more extreme weather, flooding, heat waves, drought, uh, more extreme hurricanes, more extreme tornadoes, things along those lines are all increasing. And we're losing lots of biodiversity because organisms just simply can't keep up with the rate of warming. Specific to the sea level rise, we're projecting a 3-foot rise, and that's a pretty conservative projection, but it could have these effects. Coastal estuaries, remember that's where fresh and saltwater meet, they're going to struggle. Wetlands and reefs and deltas are now going to be 3 feet lower underwater, deeper underwater. That'll destroy our coastal fisheries and potentially cause them to move inland some. Flooding of low-lying countries and cities. Think about the Maldives that we looked at in class. Think about places in the United States like Miami that would be flooded in a major way. And in saltwater invasion of coastal aquifers, we looked at that a while back, but that's where saltwater gets into your aquifer and, for lack of a better term, poisons your water supply with salt. Here are the areas that would potentially be underwater with a 3-foot rise. That's a good chunk of Florida right there. It's a good chunk of the Keys and the Everglades and things like that that'll just be now part of the ocean. Some regions will experience increased droughts. Some will have more heat waves, hotter heat waves, and expansion of deserts, while others are going to go the other way and have a lot more rain and precipitation. Our climate overall is changing. It's not just getting hotter and drier. Some places are getting hotter and drier. Some are getting colder and wetter. Up to 85% of the Amazon rainforest could be lost and converted to savanna. Remember, we talked about the main difference there is the amount of rainfall. So if we lose some of the rainfall in the rainforest, we're losing the trees, and we're going to be converting to savanna. 25 to 50% of the world's species could face extinction, especially those that live in either equatorial or polar ecosystems. Sort of the two extremes will feel it the most, while the middles hopefully will be able to adapt and survive somehow, some way. Insect and fungi populations could explode because they are broad niche organisms. They can survive in many places. And then we'll lose crop diversity because, again, some things just won't be able to keep up. There are, of course, heat-related health risks. There are asthma-related health risks, spreading of diseases and things like that, where the vectors, like the mosquitoes, can move into new places. That's certainly an issue. Economic costs of drought and flooding, those are going to be huge. Food and water scarcity, we talked about some of the sources of water scarcity and food scarcity. Really, if we lose biodiversity, there's a good chance we're going to lose a food source. If water gets poisoned by salt water, we're in trouble. So all of these things could and probably would follow the climate changing. So that's 16.2. I'll pick up with 16.3 in the next video.